Hi, good morning all. I am Dr.R.Meena Prakash, Associate Professor EC, P.S.R Engineering College, Sivakasi. And I welcome you all to the course on Robotics and Artificial Intelligence 191 EC 71. So, previous slide. So, we are going to see Unit 1, previous slide. The topics we are going to cover are types of robot, technology, robot classifications and specifications, degrees of freedom and degrees of motion, and manipulation of robot components. So, these are the topics we are going to cover today. Next slide. So, coming to the historical development of robot, Carl Sapek in 1922 introduced the word robota, and the meaning for the word robota means slave worker. The word was translated into English as robot. Isaac Asimov coined the word robotics, and there are three laws of robotics according to Asimov. A robot should not injure a human being or life. This is the first law. A robot should obey the orders of the master without conflicting the first law. So, this is the second law of robotics. A robot should protect its own existence without conflicting the first laws and second laws. So, this is the third law of robotics. Next slide. In 1954, George Devil developed the first programmable robot. In 1962, the first industrial robot was developed in General Motors, USA. In 1967, Unimate introduced the Mark II robot to Japan for spray painting application. In 1968, intelligent robot called Shake was built at Stanford Research Institute, which has three rotation motions called articulated arm. And in 1972, IBM developed rectangular coordinate robot, and in 1978, Unimation developed a polar robot called Puma, and in 1983, robotics became popular subject since 1983. Robots will be able to receive general instructions and will translate those instructions using artificial intelligence to a specific set of actions required to carry out these instructions. So, they will be able to see, hear, feel and apply a precise measured force to the object and move under their own power. Future robots will have many attributes of human beings. Robot technology comes through a lot of development, and it involves a lot of interdisciplinary subjects like mechanical engineering, electrical engineering, computer science, industrial engineering, material technology, manufacturing system engineering and social sciences. So, definition of robot. Robot is a machine seemingly works like human beings. Like human beings it will work. A robot should have all features like eyes, legs, hands, etc. with thinking capability similar to humans. The first is successful application of robot manipulators. So, the manipulator means created from a sequence of links and joints, involves some sort of material. So, this figure shows a robotic manipulator. Next slide. So, there are several different devices used for loading and unloading machines for automated assembly. So, these are the applications of robots: automated assembly, welding, spray painting, sheet metal manufacturing, laser cutting, etc. And very few of them are intelligent enough. So, here we are studying about artificial intelligence, how to inculcate intelligence in robots. So, but very few of the robots are really intelligent enough to satisfy the criteria of robot. So, the Japanese Industrial Robot Association JIRA, Robot Institute of America RIA and British Robot Association provided definitions of industrial robots, and JRA specifies 5 different levels of industrial robot. So, they are manipulator, which are directly operated by human robots, then sequence robot, which falls into further 2 categories that are their fixed and variable sequence robot, playback robot which executes fixed instructions, numerical robots which execute numerically loaded information, and final one is intelligent robots. So, these intelligent robots have their own sensor based system which helps the programs to make decision in real time. So, in the robot systems it learns itself during the tooling or programming stages. So, it learns by itself. A robot can be used for multifunction operations such as pick and place, welding, spray painting, etc. There are also many other applications of robotics in areas where the use of humans is restricted or prohibited or undesirable. Say for example, undersea planet explorations, satellite retrieval and repair, diffusing explosive device and working in radioactive environment. These are the places where humans cannot enter into and work. Next slide. So, classification. So, we will concentrate on the classifications of the robots, and according to there are according to 6 categories we can classify the robots, which are general classification according to generation, intelligence, structural capabilities, applications and operational capabilities. First we will see based on the general classification. Next slide. So based on the general classification, industrial robots for multiple applications can be classified as manipulator robot. It involves working together with other pieces of automated or semi-automated equipment. So it is jointly working with other pieces of equipment. So such as loading and unloading, spot welding, spray painting, etc. They are called manipulators. Next slide. So there are 3 broad classes of industrial automation. One is fixed automation, programmable automation and flexible automation. In fixed automation is used where volume or production is very high. If the production is very high, we can go for fixed automation, and if the quantity volume is limited, we can go for programmable automation. So here products are produced in batches. When one batch is completed, the equipment is reprogrammed to process the next batch. Another classification is, next slide, flexible automation. So here different products can be made at the same time on the same manufacturing system. So this type of is called flexible automation. And manipulator robots are commonly used for programmable automation and flexible automation. They can be programmed to move its arm through a sequence of motion patterns over until reprogrammed to perform the same task. Next slide. So a manipulator robot, you can see, feel and hear, is called the smart robot. So there are 3 types, clever robot and smart robot. So the smart robot can see, feel, hear, sensors are used. So commonly used sensors for these intelligent activities are tactile sensor, which means touch sensor, machine vision, range finder, proximity, which means sensing at a close distance, and miscellaneous sensors based on the system. So this is the thing I have explained. Tactile sensor means touch sensor, sensor. The capability of robot to use speech synthesis to communicate information about about its task and environment is widely used. So here speech is also used, speech synthesis is used. Teleoperator or master slave devices were developed using the Second World War to handle radioactive material. So that robot can be operated at distance. So that is called teleoperated robot. And the prosthesis is an artificial device to replace a moving part of an office. Suppose a hand is injured, so to replace the hand, artificial hand can be fixed. So such things is called prosthesis. Next slide. So work is in progress to develop an artificial hand with attributes similar to those. So it takes signals from the brain. So this prosthesis device takes signals from the brain, but the electrode sends the brain signals. So these nerve impulses are processed electrically by special purpose computer, which in turn controls the motion of the substructure such as limb or hand or leg. Next slide. So the next another category is exoskeleton. So this is external to the body or a moving part. Next slide. So exoskeleton is a robot looking like external supportive structure of an animal or human being. So here also there are collections of mechanical linkages to surround human limbs or entire human frame. They have ability to amplify human power, but care should be taken since it has increased, since we can feel some increased forces or speeds that are possible. Next slide. So this is a robot called cyborg robot, which is similar to human being. Next slide. So a biological type of robot carrying all capabilities such as human being, which is linked with one or more mechanical devices are called cyborg. It has artificial intelligence and some of physiological functions. Another type of robot is cyborg, which has computational capabilities in addition to the physiological functions. So the future research will give nano robots of cyborg and cybot. Next. So first we have defined the classification. Next classification is based on the generation of the robots. So at present generations can be at present 3 generations can be identified, and the 3rd generation is in the research stage. 4th and 5th generations are still in function stage. First generation robot operates according to strict and fixed sequence of events. They are also called dumb robots. They cannot hear, since they faithfully reproduce whatever we programmed, they will reproduce. Next, they will not be able to sense. So they are called dumb robots. And first generation robots cannot detect any change in the surrounding environment, and therefore they cannot modify their actions. So whatever we program, they will do, and they have no sensing power or computing power. And the 2nd generation is called clever robot. they are equipped with a range of sensors and the necessary computing power to modify their actions in response to small detectable changes in the environment. So, by sensing small detectable changes, they will be able to modify the action. So, such are called clever robots. First one is dumb robots, second one is clever robots. Next slide, and the third generation, previous slide, and the third generation robots are called intelligent robots. So, they also have the additional capacity of decision making. So, they depending upon the environment, they have the decision making capability. So, and here the artificial intelligence techniques are built in. So, they will be characterized with the ability to make, they are planning, reasoning and knowledge. So, these are the three things which have been inbuilt in the third generation of robots that will lead to AI in robotics. Next slide. So, fourth generation robot will have all the functions similar to a human and intelligence similar to human beings. Fifth generation robots will exceed our intelligence. So, fourth generation, hence it is more complex. It has high physical strength and intelligence than human beings. So, this is about classification based on generation of robots. Next classification is based on the structural capabilities of robot. According to structural capability, robots are classified as fixed robots and mobile robots. In a fixed robot, base of the robot is always fixed, and whereas the mobile robots can move. And the fixed robot acts on open chain mechanisms. Next slide. So, according to the structural capability, previous slide. According to the structural, next slide. So, here this diagram shows us the fixed robot on pedestrian and fixed robot on support rail. As you see, so the base of the robot is fixed and the other end is manipulator. And the end to the manipulator is connected the end effector. Next slide. And this is the gantry framework of steel bars raised on side supposed to bridge over something. So, here the end effector, so the robot is on overhead, robot is fixed overhead. Next slide. So, this is a fixed robot on a track. So, the end effector, so always there will be an end effector at the end of the manipulator. So, the next slide. So, mobile robots have the locomotive mechanism to move, they will be move whatever the surrounding environment. Wheel robots are called automatic guided vehicles. AGVs have built-in power system, so they need power and they have mobility tracking devices. Wheel robots can move on smooth surfaces, so the terrain has to be smooth. Next slide. Walking robots are robots that imitate human beings or animals by having the ability to walk on 2 or 4 legs. The most common way of defining the path of AGVs is by means of a guided wire bed buried or under the surface of the floor. A walking machine is assumed to operate over rough terrain. They must be highly adaptive to irregularities of the terrain. So, even though the terrain is have some irregularities in the surface, it should be able to walk. Next slide. So, the factors that must be considered in designing the walking robots are number of legs, gait selection, that means posture selection, balance and coordination of the legs. All the legs have to be coordinated and balance should be there. And the classification, we have 1 leg, 2 leg, 4 leg and 6 leg mechanisms are available. 2-legged robots are called biped robot. Next slide. So, these are the examples of diagrams which illustrate the 2-legged, 4-legged robots. Next slide. And fourth classification is according to the intelligence. According to the intelligence, they are classified as low technology and high technology robot. From the name itself, we understand that low technology have somewhat very limited capacity and they do not use servo control. So, low technology robots don't have servo control, whereas high technology robots have servo control. So, to indicate relative positions of the joints. So, to indicate relative positions of the joints, their control system is intended for single motion cycles such as pick and place components. So, pick and place means a node sensing of the environment. So, it has just to pick and place. So, this is called the low technology robot. So, they don't have any servo control mechanism. Next slide. So, high technology robots are servo control systems. They accept more sophisticated sensors and programming languages. So, we can program it, more programming languages can be used. So, they are called intelligent control robot. It is capable of performing some of the tasks that are carried out by us, our human beings. See, they are, so to behave like human, they have to be equipped with a variety of sensors and a sensor apparatus for visual capabilities and tactile capabilities to instantly respond to various situations. So, instant response should be there. The intelligence robot should respond in instance. Next slide. So there are three categories: alpha, beta and gamma in classes of intelligence. Alpha class of intelligent robots expose and adapt the environment for a particular task. It has no facilities to remember from the past experience, whereas this beta class of intelligent robots have additional memory and they work as small robots in a specific environment, whereas gamma class of intelligent robots works like human beings which observes and evaluates the immediate environment. They have knowledge, reasoning and planning. So they have the capacities of knowledge, reasoning and planning. So such type of robots are called gamma class of robots. Next slide. So then it makes the appropriate decision according to the perception. Next slide. Operation capabilities. So we have discussed about the classification based on technology. Next classification is based on the operation capabilities of robot. So there are limited sequence controlled robot, playback robot, controlled path robot, adaptive controlled robot and artificial intelligence robot. So limited sequence controlled robots do not use servo motor. So they operate by they have some hydraulic or mechanical operations to operate. Next slide. So this limited sequence robot simply picks the object from A and places it in B. Next slide. So this control system is intended for simple motion cycles such as pick and place. Robot picks up parts from one location and places them in another location. So next slide. Next one is playback robot. So it is first guided through certain set of actions by an operator, then repeats the same action. So whatever we teach to the robot, it will play back. So it is called playback robot. So whatever we teach, it will be playback. Next slide. So in the playback robot, an operator uses a teach box, which may be an integral part of the body or it may be operated remotely from a system. The robot joins or moved with a teach pendant. When the desired location and orientation is achieved, the location is entered into the control. So whatever we have programmed, it is entered into the controller. Next slide. Then it will be playback. So the playback robot, then whatever we have programmed, it will be played back. So this is called the playback robot. Next slide. Next one is controlled path robot. So this controlled path robot has a non-servo operation or servo operation. Servo control uses position of 4 sensors that supply information about the actual path or arm. Servo control means closed loop. Non-servo control means open loop. So servo control mechanism uses 4 sensors that supply information about the actual path of the robot. Accordingly, the decision is taken. So that is called the closed loop system. Next slide. So the robot takes a corrective action through the controller. It may be controlled by point to point, straight line path or continuous path. Next slide. So this is the continuous path controlled robot. It is capable of performance movements along the controlled path. With CP from one control, the robot can stop at any specified point along the controlled path. So typical applications include spray painting, arc welding and gluing. Next slide. So the adaptive control robot must be able to handle the task that calls for some sort of intelligence. So this adaptive control robot should have intelligence instead of fixed control robot. So this artificial intelligence has 3 stages, namely perception. So first it has to perceive about the surroundings, then recognition. So based on that recognition, action should be taken. So perception translates the signals from words into symbols, recognition translates symbols into signals, and actions translate signals into images that affect the path movement. So once it perceives the surroundings, so it will take actions according to the perceptions. Next slide. So classification according to use. This is the last category. According to our use, it is classified as automatic manufacturing, remote exploration, biomedical application, hazardous material handling, service robot. So these are the classification. As we know, automatic manufacturing means manufacturing for example, in the manufacturing plants to move objects from one place to another, we can use automatic car assembly. So this is one of the example of automatic manufacture. Remote exploration. So underwater sea exploration, satellite exploration. So these are examples for remote exploration. Biomedical exploration. So we have hazardous to remove the hazardous waste we can use for biomedical application, and hazardous material handling, nuclear power plants we can use, and service roads. So say for example, during corona times we can use robots to deliver medicines to the affected patients. So these are the classifications according to use. So we have in this class we have discussed in elaborate about what are the 3 laws of robots. So firstly, discussed about history of robots, and then we discussed about the 3 laws of robots. So 3 laws of robot. So first law says that robots should not harm the human beings. Second law states that it should obey the human orders, and like that we have discussed about the 3 laws of robotics, and then we have discussed about the classification of the robots under various categories, like classification according to use, classification according to technology, classification according to the first generation, like that we have according to the application, like that we have discussed and elaborate about the classification of the robots. Thank you, Ananda.